I'd like to welcome everyone to our College of Architecture, Construction, and Planning speaker series. Today's speaker will be Joseph Wheeler. He's a professor of architecture at Virginia Tech College of Architecture and Urban Studies and a co-director of the university's Center for Design Research. Joseph is a globally recognized innovator in the areas of housing, industrialization, environmental sustainability, and technology integration. As a leader of Virginia Tech's Future House project, Joseph has spent over a decade helping student researchers, as well as industry, government, and academic partners explore solutions to the world's global housing challenges. His area of expertise include smart home technology, the use of modular and industrialized processes in home building, energy efficiency and green innovation in home building, housing accessibility for diverse age groups and aging populations, and the engineering of flex spaces for smaller homes that still deliver on occupants' needs. Joseph's teachings and research has long focused on areas of environmental and sustainable design. As co-director of the Center for Design Research, he has led interdisciplinary solar decathlon projects in 2005, 2009, 2010, and 2018, with the aim of building the world's best solar home. In 2010, Virginia Tech's entry, Lumen House, won first place overall in the international competition in Madrid, Spain, as well as the first National Honor Award for a university from the American Institute of Architects. Most recently, further validating his future building concept, his Future House Dubai won first place overall in the 2018 Solar Decathlon Middle East. And in a few weeks, the student-led Future House project will be on display in Times Square before being moved to Dubai, where it will be on display for 6 months. Everyone, please welcome Joseph Wheeler.
Can you hear me okay? Color's a little off on this. It's not that color group. Thank you for inviting me. It's really nice to get away from Blacksburg for a little bit to a whole nother part of the country. It's warmer here. As the introduction stated, I've been involved in the Solar Decathlon project since the beginning of the Solar Decathlon. I don't know if you know what Solar Decathlon is, but I'm sure you do. It's the Department of Energy. It started as a Department of Energy competition that challenged university students to design, build, and operate off-the-grid solar-powered homes. Initially, it was off-the-grid, and now it's grid-tied, right? Because the technology is changing so fast. These are great projects for the students, but also great projects for the industry, because it really is encouraging us to really look at where we are today and try to figure out where we need to go in the future. This 2002, 2005, those two houses were really big, I think, learning curve for us, because we found that competition, actually, you have to build the houses on your own campus, and you have to move them. Early on, it was to the National Mall in Washington, D.C. And you had to build them fairly quickly. You had to erect them in one week, and they had to be functioning. And it's pretty difficult competition, because you have to generate all your power from the sun. And at the time, the batteries, it was off the grid. You had to do all the tasks that you typically do in a house, including make all your hot water and keep the temperature, the HVAC, 72 degree range, control humidity, and you had to charge an electric car. What we discovered from the first two is that you really have to do most of the work on your own campus to get the more sophisticated systems working before you take it somewhere. And this is a lesson that we've learned from the Solar Decathlon that has actually, if there's some things we learned from Solar Decathlon, it really is how in the future, as we start to expect our homes to be more and more like our phones and integrate more and more technology and start to incorporate renewable energy and be somewhat sophisticated, we've got to get away from building the way we build today, and the way we've been building for 100 years, right, conventionally. I'm showing this. This isn't the future house. This was the Lumen House. It was a 2010 project that won the competition in Madrid, Spain. It was our first attempt at a smart home. We called it responsive architecture, where, up in this corner there's a weather station, and the house would read the weather and set certain kind of components of the house into position to basically prepare the house for that type of weather, that specific time of the day. So it was our first attempt. We worked with Siemens on home control systems to make this thing work. One of the more innovating parts to that was this frame that we built that was tied to a transportation system, a standard gooseneck and bogie that typically carries a kind of they call it a double drop lowboy chassis. And instead of a chassis, we custom built this frame, and it allowed us to get this house anywhere in the world really quickly and really easily. And I like to say we arrived in Spain, I like to say gift wrapped, right? Because we arrived like this. Once we took this plastic off, I mean, everything was complete in the house. It was already done. This is where Barcelona was, this is where Grenoble was, and this is where Stuttgart was. I think second, third, and fourth place in the competition. Well, we were first. We were up and running just a few days into setup, where you can see how long it took the other teams to get moving. We learned a lot from this competition, and again, a testament to how movable, how transportable this is. We were able to get this on the mall. We were in Madrid, Spain. We had this house on Times Square, which to me, it's like a once-in-a-lifetime opportunity to get anything on Times Square of this scale. Just out of just great fortune, we were called just the other day to present the Future House on Times Square for Design Week, NYC by Design. And then it was in Chicago, in Millennium Park, right here, opposite B. So, in about 6 hours, you can hook up to this house and move it, anywhere you need to move it. We were even invited, since we were in Chicago, while we were there, we were invited by the Farnsworth House, the curator of the Farnsworth House, to exhibit this on their property. It was there for a year, the Farnsworth House. I got to sleep in this house. It's great. Much better than the Lumen House. So this is the inspiration. And this is what we're trying to move towards with our research is like I said, as we start to expect our homes to be more automated and have more sophistication and more energy efficient, we have to really rethink, how we build them. If you look at how a car is manufactured, it really, takes advantage of that factory environment and the factory process, the industrialized processes you perfect something, you mass produce it, and the systems are installed in a clean environment where you have localization of all your trades, all the inspections happen at the factory, and what we're proposing is you take a lot of the problems that happen in construction and move them into just a much better situation. You also look at the environments of these industrialized products that we're used to seeing. I mean, they're beautiful, they're well designed, and they're industrialized. You don't see any drywall in a plane. You don't see any drywall in a Tesla. They're molded components. They're snap-in. There's a thought behind the details, and there's also access to a lot of the digital systems that are embedded within the walls of a lot of these products. You look at a Tesla, the interior of a Tesla, I mean, it's got everything. It's got the safety, it's got the efficiency, it's got the environmental controls, the comfort, the customizability, And you know, it's perfected and mass produced. This is what we're dealing with houses. And the one thing I'm noticing in trying to work with builders, I do talk a lot with like KB Homes and D.R. Horton, you know, a lot of the production builders about the possibilities or the future of moving this direction. And they're very interested in it. They're interested in it mainly because they see the next housing crisis, the next housing boom that happens, that their problem is going to be the trades, not having enough skilled craftsmen, skilled tradesmen to spread that far out to build all these one-off homes, you know, all over the country, right? So they can see where they need to, you know, get their act together and think more about industrializing. Probably why we see, I think, Katerra, the housing group, doing so well right now is they're moving in that direction. So Future House is it's about a 6-year-long research project. What it proposed initially was components of houses that were factory built. So in 2014 we did a kitchen of the future. 2015 we did a bathroom of the future. 2016 we did a living room. We do a different room, you know, every year, and we would spend a year kind of focusing on, you know, how do we think? How do we take technology and integrate it, you know, effectively in these spaces? Apply some common sense, kind of eliminate some of the kind of just the gimmicks that you can find with, you know, anything IoT or electronic, right? We still run across those, but we quickly try and, you know, get rid of them. But this was earlier on when we were looking at how you would build apartments or medium density housing, but we were still kind of stuck on the big box modular. The problem with this big box modular is transportation. Even that Lumen House, even though it was quick to pick up and move anywhere really quickly, you still had to get all these special permits. You had to close down roads. You couldn't come into the city, New York, you know, until midnight. Special permit to cross the bridge. You can't get to, you know, down smaller roads, you know, so it'll take out the possibility of building, you know, in remote, you know, more rural areas. So what we realized is, this is the plan of the Future House, is rather than the big box modular would ship space and the components. If we reduce the components down to what we call cartridges, components that are small enough that they'll fit on a flatbed truck without being oversized, 8'6" width maximum, then you can plug these pieces together, they plug and play on a site, kind of like Legos. And then the space actually happens after you arrive at the site. You know, you put a wall up here, and your space, you know, comes on the site, right? It's a very practical thing. What we've done is we have electrical subpanels at the end of each of these cartridge units. And then we have one cartridge component that runs right down the middle here. It's a 30-foot long cartridge that sits above the hallway. And that's running all of your home run electrical and communication lines and ductwork to the different rooms and different components of the house. That all ends here where it ties into your main hub, the brain of the house, which is the, you know, electrical mechanical room. I'll talk more about that later, but, you know, there's the proposal. Future House, you know, in a few weeks we'll be unloading these things from trucks and setting them up just like Legos on Times Square. We get this house set up in one day. The superstructure of the house dried in with functioning components in one day. I'll talk more about it. The first year, 2014, was the kitchen of the future. This was 2016, the bathroom, AV wall. There was a bedroom that had a home office. There was a entryway, which is in a coat closet, and a little study closet that sits between 2 bedrooms. There's a mechanical unit. You can kind of see the plug-and-play components, the laundry. And every year we would do these projects. So the first one was the kitchen. We started with CNC process, right? We ordered structural insulated panels to size. These pieces were CNC cut on a gantry CNC saw. When they arrive and you assemble this, you get absolutely precise dimensions, right? It's cut by machine. When this goes together, it makes the perfect site for installing the cabinetry. It's every cabinet installer's dream to come in and be able to install your cabinets in walls that are square and true, right, and precise. But what this does, if you can imagine, also gives us the opportunity to install all of our electronic systems. In this case, we have a backsplash, electronic touchscreen backsplash for the kitchen, and automated doors and integrated lighting. A lot of technology for aging in place, like adjustable cabinets, things. This was the kitchen, so this went to the National Builder Show and the Kitchen and Bath Industry Show, KBIS, in 2015. And it was, the idea is really more provocative, is to say, hey, let's think about the future. So there's your digital backsplash, electronically controlled, so mixing valves, so you can, with the interface on the backsplash, you can control the temperature of your water and the on and off. We're integrating the induction technology under the countertop, so when you're not cooking, you have to have more counter space to work with. We're injecting soap into the dishwasher based on the weight of the baskets in the dishwasher itself. So there's a lot of work we're doing with computer science, taking appliances and saying, how do we really make these things smart? The appliance manufacturers, the sales guys that say, hey, you can control it with a phone, therefore it's smart. No one's going to control an appliance with a phone. The interface is already on the face of the appliance. Why would you, you're actually making it more difficult to operate. We're trying to search for ways for this to be more autonomous. Like if you go to cook something, you put something in the microwave, can it automatically read, maybe through the barcode, what time settings, what temperature settings for it to be. In fact, in our microwave, we're even installing temperature sensors, so we're monitoring the temperature of the food that you're heating up. And when the solid state technology of a microwave gets advanced enough that it can cook food evenly and not so, so correctly, it can be a really useful sensor. Oh God, it's projected really bad. We are monitoring our cookies on the screen. Is there a way to adjust the color on the projector? Is it always this bad? Oh, okay. You guys are used to it, right? So we're monitoring what we're cooking. We're looking at a coffee maker that can be pre-warmed with activity that's happening in the bedroom earlier on in the morning or in the shower. What else are we doing? The soap dispenser, when that dispenser runs low, we're monitoring the weight of that soap dispenser so we can know when to order more soap. Now we've got the Amazon Dash thing going, so now when it's running empty, you can automatically order the soap for you. So you can see this isn't really architecture. This is a lot of work on the computer science side, just exploring this technology. But it's really helpful for those computer science people to be working with the architects and the interior designers and the industrial designers so they can communicate about design. One thing you'll see about Future House is there are very few wires, all over the place. It's really about integration and making the technology kind of go away. even integrating downdraft into the top. Here's the load cell. Okay, this little plate has 4 pressure sensors on the 4 corners of the double sandwich glass pieces, and that's measuring the weight of the milk container. Okay, so when you're at the grocery store, you can actually, you can log into with your phone, you can access your refrigerator and see how you're doing on the milk. What we're working towards is a 3D printed shelf of a refrigerator where we're actually going to print in the load cells in a grid so that we can recognize which cells are activated, so you can get a footprint of that milk container and know the weight of it. And therefore, you don't have to always put the ingredients in the same place. This gives very specific footprints of a carton of eggs and a gallon of milk, or a half gallon of milk, or butter, You can do the same thing with the pantry. Even the popcorn for the microwave, we've installed a microphone, so we're listening to the pops, the frequency of the pops of the popcorn, and when it finishes popping, the microwave turns off. And the beauty is here that very complex, very sophisticated kitchen can be folded up and packaged in a 2'6" wide by 18 foot long by 9 foot tall carpet, gift wrapped like Lumen House. The next year we did the kitchen. This was a collaboration with Kohler Corporation. Kohler really liked what we were doing with the kitchen, and they wanted us to jump in and really propose what can be done with their fixtures. Just 2 years ago, Kohler hardly had any smart products on the market. So this is moving so fast. Alexa's like taking over the world, right? We're trying to do all of this without Alexa. We're trying to keep your home private, right? From giving away too much information. What do we have? Thinking of aging in place. Okay, through a LiDAR, which is basically a radar system that can map the user that's in the space. It can detect how tall someone is. So this is without a camera. It can detect how tall you are. And it will adjust this countertop, this vanity top, up and down to the height that's ideal for the person using this. A child brushing their teeth versus an adult, versus someone in a wheelchair. Right? So someone in a wheelchair can live in a home with someone not in a wheelchair, and you have usable fixtures throughout the house. We're doing the same thing with the toilet. We're applying actuators to the base of the toilet so that the accessible toilet, which is a certain height, once the person sits on it, can actually lower to the proper height for ergonomics, right? For the correct position that a toilet should be in. Because these accessible toilets are very, very awkward. But think about a child in potty training. If you could lower the toilet down as low as possible so a child can get on and off on their own. In that same note, grab bars that are removable. So you don't always have the grab bars in a place. They just unsnap from the wall. You keep them in the closet. When you have that skiing accident, you pull them out. Right? Or you invite someone over that may need them. Aging in place, so that you can live in a home from when you're young all the way until you're a senior and never have to move out of the house. Some over-the-top things, but I still think really good. Kohler, since working with us, has come up with an automatic tub filler. This is pretty neat. It's by applying an actuator to the stopper, you can open and close that stop and release or build up the water in the tub. There's sensors installed in the walls so that once the water reaches a certain height, it'll turn off the water. So you can now, with your phone, remotely, you can order a tub at a certain temperature for a certain time of day to be ready for you. Think of a parent with kids. If you had the tub automatically ready at 7:30 every night, like at least me, guaranteed, those kids would be in that tub, right, ready for bed. So is this practical? Maybe, maybe not. But it seems to be practical enough that Kohler has run with it. And now they're making this a product. What we're doing with the other faucets is we're taking the electronic mixing valves they use for the really fancy shower systems, and we're stripping them down, making them one unit, and using them for the faucet of the bathroom and the faucet of the kitchen. So now we get that fine-tuned controlling of both of those units. We are making our own smart mirrors. It's pretty easy. Touch film, mount a TV from Best Buy behind it, and you've got a interactive, with a two-way mirror, interactive touch mirror. It's getting pretty affordable to actually make these things. You're going to see the prices come down and down as we go further. The NUMI toilet is a showcase on its own. It's have you seen this Kohler toilet? It's got a built-in bidet. It has an air freshener. That's an FM radio. It's pretty crazy, over the top. We're looking at surfaces in the house, waterproof surfaces. We're looking at sanitary surfaces, antimicrobial finishes. If you're building modular components, do you need grout lines in the floor? Can you start installing full sheets of tile, full sheets of glass, for the tile? Here, in this case, it's glass with acid etch pattern. Monitoring our soap, our shampoo. And here's the bathroom. Okay, so this bathroom is two-sided. So that bathroom I just showed you is half of this. It's the front side. That's the master. The guest bathroom is on the other side. So when this sits down in your floor plan, you've got all the systems you need for both bathrooms. The third one was the living room. This was exhibited at the AIA conference in Atlanta. What this is really about smart lighting, and a whole semester, two semesters of students looking at sensors and trying to find ways for the home to identify specific tasks that the users are doing. So if it can differentiate whether you're working on a computer, reading a book, watching a movie, or cleaning, and then it's going to give you different lighting settings to better accommodate that task. And of course, it's made of cartridges. So this is one modular wall, the other modular wall on the other side, right? And then you bridge across them, and you've got your space. We're looking at door portals, we call them. So, in the future, our door is going to be all automated. In this case, sliding doors. In the future house, we actually have 3 doors in every portal. One that's clear, one that's frosted, and the third one that's a bug screen. And the home automation system can control, it has access to your door, so on a beautiful day, it can automatically open the 2 glass doors and close the screen door if it can work passively, save energy. The 2 glass doors that we use, one is frosted and one is clear. Both of those glass units are R8. It's a very high insulation value. So when they're both closed, you get an R16 envelope, which is almost as much insulation as a standard residential, insulated wall to code. So you can see how the house would have control, to be able to insulate itself when the weather's extreme, right? This is Mohammed. He's working here on multimodal ways to interface, to open the door. So fingerprint ID, facial recognition, voice control. It could be a fob. So there's different ways, and I guess it depends on how secure it is. It's the front door of your house, so you really want to make sure that it's that it's secure. But that multimodal is really important for user kind of preference. It's like I always feel silly, on my phone talking to Siri, asking her to call someone, when you're out in public. Same thing at your home. You don't want to be talking to your house. It's just too goofy. It's too, it imposes on your privacy. So can we figure out a way that the house can be as autonomous as possible, or predict what you're doing? There is another extreme, like the Nest thermostat. I personally cannot stand. They call it a learning thermostat. It learns. Yeah, sure, it learns what you like, but it also learns your bad habits as well. You wake up in the middle of the night, you crank it down, and every night after that is going to crank it down, right? So, there's got to be better ways, and I think the whole industry is trying to work this out. It's new technology, it's awkward, and we're trying to figure out how to do that. And our program is exploring this, where we have the luxury of having architectural environments as a test bed to try this stuff out on. Whereas otherwise, you go to CES, Consumer Electronics Show, and just see thousands and thousands of just devices. Devices that are actuated, controlled by Alexa. The next year, we did a home office. This was a bedroom and a home office with a closet that sat between them. The exploration here was on a concept called flex space, to where we had this moving closet wall which could move back and forth between the two rooms. So during the day when you're using the office, you can push that wall out of the way and make more space for the office. If you want to do the laundry in one room, you can push this out of the way and access the washer and dryer, or the opposite, you can access the washer and dryer from the bedroom. You can make a dressing room, you can make a conference room, and then this is a Murphy bed, but it's not an ordinary Murphy bed because we're using electric actuators. Now it doesn't matter how much that mattress weighs, because the actuators can lift it. And it's motors that are driving this thing. So now we're able to use the Tempur-Pedic frames and the Sleep Number 360. So they're very comfortable beds that you can stow away. So think of the impact on the hotel industry. If you go to a hotel, you only sleep there at night. You can use the hotel as an office during the day, get the bed out of it. Or dorm rooms. We've got a developer who's looking into incorporating these smart beds in, on a single wall that serves 2 rooms on either side. If they're able to lift these beds up and make living rooms during the day, they found out they can actually take 12 inches of space out of each dorm room without losing really usability, and they're saving a lot of money. So you're making them smart, you're saving money. So, and then on the back side of the bed is a sit-to-stand desk for the office. It's also actuated. The smart mirror, where you can manage your wardrobe. You go to Macy's, every item of clothing in Macy's now has an RFID tag in it. So what we're doing is proposing that if there's a way we can locate your clothing with RFID, is this going to change the way we lay out, say, an apartment, where you don't have to have a closet in every bedroom. There's the closet that's part of the laundry room, and you just find your clothing through your iPad. This is a really good one. Deployable insulation panel. So just like it's a modern version of a shutter, right? But instead of for privacy, this is giving you insulation. So if you can take that insulated glass unit, which is about R1.5, and deploy a insulation panel over that, which is R22, when you're not home, you can have a better insulated home. When you're sleeping at night, it's better insulated. When you go to the grocery store. So you're relying on the home automation system to just manage the envelope of the house. So all of those projects that I showed you just now, there was 12 of them, 12 cartridges. They were lost in a fire in 2017. Yeah, it was kind of sad to see Notre Dame today. It's just the same kind of feeling inside. This is just horrible. So we lost everything. It was a faulty heating system. They just 2 days before replaced all the valves in the propane heating system through this building. The building was pretty bad. It was a pole barn, and we had all this sophisticated equipment in there, so it shouldn't even have been in there to begin with. But probably like you guys, we're always looking for space to do these special projects. So anyway, we lost it, and we were kind of stuck. It was about $2 million worth of research gone overnight, and so we soul searched for about a day and decided, even though we won the Solar Decathlon 2010 in Madrid, we're going to enter a new Solar Decathlon, and we're going to use this as a way to rebuild everything that we lost. But it will be Future House 2.0, right? So better, smaller and better, not bigger and better. So that was that. Now I'm going to for this talk, I'm going to step aside and show you projects that happened within those 5 years as side projects, because we love this idea of cartridges so much that we were exploring it. So one summer, me and two of my past students, we were curious to see if this would work just for a typical house, right? Not a smart house, just a market competitive house. So we bought a piece of land. We took out a construction loan, bought a piece of land for $60,000, construction loan for $250,000, and we designed a 2-level, 2,200 square foot house that used 22 cartridges. We rented a little warehouse space. We built it ourselves. Not the warehouse. We built all the cartridges, all 12 cartridges. We built them in 30 days, in 1 month. We convinced the local inspector in Charlottesville to come out and pre-inspect these units at the warehouse. And he was willing to do that. We're kind of lucky, because most inspectors would not do that. They wouldn't let us touch this. But he knew we were from Virginia Tech, which was a little better school than what's in Charlottesville. With some university. Yes. Good basketball team. And we built these. So here's a typical downstairs cartridge. Okay, it's 16 feet wide, 3 feet deep. It has the pre-finished interior. We're not using drywall, except where still the code is requiring us to use drywall, which is a 30-minute in every horizontal surface. But pre-finished, this integrated structure, because they're SIPS panels. Insulated, because they're foam. SIPS panels are sandwich foam panels. And windows and home runs for the electrical lines. So these were sized to reach in one run all the way to the main breaker panel of the house. We rented a way oversized crane, not really for drama, but because this a huge bank of trees over here that we didn't want to have to remove to get these things in there. So we got a crane that could lift over them. Really was not much of a difference in cost, and it made great photographs, right? But have you ever seen a kitchen go in with the appliances in place? And that was the case for a lot of these. Cabinetry, lighting, wiring, finishes. Now the beauty is that we got it to that point in 1 day. Yeah, you have to, because the crane, $3,000. You have that crane for 1 day, let's get these things in. But the beauty here is it's not that it's just dried in, but it has most of the systems already pre-installed. Okay, so now much less complexity in trying to finish out the house. Really what we did is we installed the floors, ran our ductwork in the interstitial floors between that first and second layer, and ran all our home runs through there, and then installed the floor and the ceiling. So it's pretty fast. It's sold for market price, our asking price. We made a profit, not a big profit, like $75,000, but we think we sold it for too low. They have a power plant. One of their 4 power plants that feed power to the whole city is run by photovoltaics, and it's going to be growing. They also have a solar research center out there. So they wanted to get the population out to see this research. So what they do, they stuck us in the middle of the desert. This is really, really bad. So 18 cartridges, 5 trucks. Now these are flatbed, single drop flatbed trucks. Notice none of them are oversized. So we didn't have to get any special permits. Came across the ocean, landed in Dubai, here. Very extreme, very hot, very windy. We were told that it doesn't rain in Dubai, it only rains 3 times a year. It rained 3 times when you were there. But the worst kind of rain, because it was rain in a sandstorm. Like 70, 80 mile an hour wind sandstorms horizontally. I mean, some of the other houses were like Wizard of Oz. they were gone, or parts of them were gone. So here we were. I'm going to show you a video here. Let's see. There's the front facade of the house. Let me just explain. That's 1 cartridge, okay? That's 8'6" deep, 12 foot wide. It contains the door portal, the mud room, and a powder room for the house, okay? This is a stainless steel screen that surrounds the entire house. It serves 2 purposes. One, it's shading the horizontal sun from the walls. We're trying to keep all the direct sun in Dubai. It's extremely intense there, the sun. And by eliminating, so we have this 5-foot overhang that wraps around the 3 sides of the house. That's keeping summertime sun off of our envelope. So by removing this direct solar gain off of that curtain, the envelope of the house, we're reducing our cooling load by half. Okay, so we're able to cool this house in the extreme Dubai, 900 square feet, with a 1.5 ton mini split system. Very affordable, very efficient system. The other purpose of this is the culture of the Middle East. They're very private. They like their private gardens. All the residences are surrounded by privacy walls. So this makes a beautiful enclosed garden courtyard. This was probably a couple of days before we opened. Everything was modular, even the outriggers, even the stainless steel screens. They would stack, they're 4 foot wide, they would stack. 2 stacks, and we had all the screens. Fairly quickly installed. Throughout the house, there's a kind of a band of technology to the house. You can kind of see it here. We're using Gorilla Glass that's back painted and laminated to MDF, and it can contain touch panels, it can contain exciters or transducers, so that horizontal band becomes a sound system. Essentially it becomes your interface and your technology through the whole house. We're exploring BIPV, so integrating photovoltaics into the glass windows. Oh, this is a fun one. It is about the future, right? So we've got the drone hatch for Amazon, future deliveries of Amazon. So this comes down into a closet below here, and we're talking that maybe in the future that closet could actually be a refrigerated box for groceries. So is this happening? So what the students are thinking about is, would there be an RFID reader or some kind of way that this could identify the drone, maybe tied to the tracking number, or so that it can give access to that specific drone for your house. The house, this is the powder room. So we have a vanity here where the window, the mirror, the sink, the basin, and the cabinet will raise and lower to adjust to the user's height. And the same thing with the toilet. This is a wall-mounted toilet. Now this raises and lowers. So you can see it can go all the way to the floor, where it's really low for a child, or can actually help grandma actually assist her to stand up from sitting. It's white. You've seen the kitchen before, but this is kitchen 2.0. Now this upper cabinet will raise and lower, actually here. And the lower cabinet also can raise 8 inches up and down. So we're using that LiDAR again. Now why is this great? This is great because I can now tell my 10-year-old to unload the dishwasher and he has no excuse. Notice the faucet is not on the countertop. It's actually installed in the upper cabinet. Kohler is really interested in this because they're thinking, oh, this is potentially a future product. That, you know, cabinetry installed fixtures. Actually, we're looking at a potential product. We call it the actuated wall, or the power wall. So this wall would come with the actuators and the slides that hook into your cabinet. So say you go to IKEA and order, say, a tall horizontal bases, and you know the talls come with this hardware that really easily convert that into an adjustable countertop. Flex space. So like we were doing before, home office, AV wall, bedroom, bedroom. The bed moves up. These walls this opens up, gives you an office, opens up further. This bed moves back, bed moves away, living room, office, walk-in closet, big living room, say dining room, different scenarios. So here's a cool video. This is just one scenario. So what we have is the interface on the wall. You can walk up to it, and we have 7 different scenarios. Big living, big bedroom, small bedroom. And the house will deploy. They're automated, but we have a simplified version of this where they can just be manual. It's actually I think it's even better not to be automated. But this office can completely stow away. Stop it. Anyway. And then there's the screen that spins around. So you can have the television screen in the home office for teleconferencing, or in the living room for the Super Bowl. You can see there's the interface installed. So the touch screen, that's the Gorilla Glass. This wall is one big sound system. It's really, really beautiful. How do you power the wall? We didn't want umbilical cords, running back and forth across the ceiling. So the power electronics group decided to explore low voltage power. So what they did is they converted all of the electronic systems in this wall and the closet wall. And they're powering it from DC, and they have a DC rail, a touch brush guide DC rail that it's like the third rail of a train. It's picking up its power. You don't have cords getting tangled up everywhere. Dining room table can come out from under the island. You can come into your dining room, or it can go straight out and convert your patio into a dining room. This ceiling is just a masterpiece on its own. It's picked up the same pattern that we have on the screens, but it's a grid of LED lights, RGBW, so we can tune it to any color, including warm and cool white. And there's one, I have a Master's of Science student, his thesis is architecture lighting. So he's looking at an alternative to the alarm clock. Instead of waking up an alarm, what if your ceiling simulates a sunrise? So at 6:30 in the morning, it's deep red, right? And it's slowly, gradually turning into a white light. Naturally, right? You look at circadian rhythm and that kind of thing. And there's the garden. Our landscape students were fantastic. Instead of going in Dubai, instead of going to the local nurseries and picking out all the green stuff that took a lot of water, they went to the municipality and found local drought-resistant plants and planted them everywhere throughout the house. There was a water contest. We won by far first place in the water contest, mainly because we didn't have to water our plants. We also had some great systems for recycling shower water in the bathroom and laundry water. Laundry. I mean, the beautiful thing of this, the thing about this is that it was so quickly built. There's the bed up, there's your bed down, and it's your sleep number 360. It's the smart bed, the bed that senses when you're snoring and kicks you out of bed until you stop, right? And that's the smart mirror as well. Now, this is really important. That sleep number bed is monitoring a lot of your bio information. So your heart rate, it's monitoring how you slept the night before. And so could this be tied to telehealth and ways for doctors to monitor their patients in senior housing? So that's a whole nother direction that this can go as the connected health apartment or retirement home. Here's the 3D printed sink. So this was printed in one piece. I mean, in person, it's beautiful. It's really stunning. But it's one piece. We've got 3 ports here. The plumbing, the drain, everything was printed within that one print. We went after the fact and sealed with chemistry. We sealed those pipes so they were waterproof. And then after the fact, it was coated. You'll have to go online and look at some of these images. It's my favorite shot. The cantilever, the door portal, the rain screen, which is a very affordable way to do a facade on a house. It's just insulated. I mean, it's just tempered glass, back painted, hung on rails with high strength tape. Here's our team. Like I said, we won first place in the competition. I think we are really proud at winning all of the design categories coming from the architecture and interior and industrial design side. So what is this house? It's a lot. A new way of building using these prefabricated concepts. It's seamless integration of all the smart technology, kind of making it disappear, making it useful. Flex space and being able to get as much as you can out of a small footprint. A lot of functionality. Energy efficiency, so our power electronics group kind of perfecting a energy management system with photovoltaic power. The DC powered home and venturing into that area of could one day the whole home be DC powered. Aging in place, and can you live in your house your entire life? 3D printing and advanced materials, advanced processes. 3D visualization, we're taking the VR, we're making an interactive VR model. And what we have is a model of the future house you can walk through and you can actually interact with the surfaces. So you can change out the floor to be oak, maple, walnut, tile. You go to the countertop, switch between colors of marble, whatever. But then the idea is like a 5D kind of thing where you could get the real-time cost and the delivery date from that model. So it's replacing the model home, right? So after the competition, we just got back about 2 weeks ago. And in one day, brought the crane, we set it up on this drill field in front of campus. It's so fresh there, we don't even have pictures of it yet. It's going to DC this summer. I'll be there for 3 months. This is our bad Photoshop image, but you can get the picture of this. This is pretty much what the situation will be, right in front of the TKTS, the glass steps. And we were invited, since we won the competition, and they're looking for a really good house, to be exhibited right here in the World Expo 2020. So this is November 2020 for 6 months. A lucky group of 20 students gets to spend an entire semester at the World Expo. So that's the talk. But I have two little follow-ups that are kind of exciting that I thought it'd be good to share. Because some of this super technology is a little bit excessive, but there are some practical sides to this. Not far from here, with Hurricane Harvey, okay, hit Houston so bad. What about all of these houses that have to be renovated? First floors, right? Second floors were okay. First floors, what they typically do is they go in, they gut all the cabinets, carpets, the drywall, they take it up to a certain point and they replace it all. Well, you look at all of those houses that are destroyed, that means that many contractors are coming in to rebuild all these houses. Where are they going to live? They're staying in all the hotels, the local hotels. In a lot of cases, they're coming from town. They're depleting all the Home Depots and the Lowe's, right? They're just wiping out all the hardware stores. And these people that live here or used to live here are struggling. What if you could solve this problem at a national level? What if you could prefabricate a lot of these interior systems of these homes, but have them built in Chicago and Pennsylvania, Midwest, and then ship these in and quickly have them installed? So we looked at this as a challenge. Biggest problem is if you design a kitchen that's prefabricated, well, how do you get it inside, right? Because it's 8 foot tall. Well, you build it in 2 pieces. So we did this. This was a 1-week project. It was called Kitchen Renovation in a Weekend. So this is 4th of July weekend where we built the kitchen in our little warehouse. Now this wasn't in Houston. This was a project that we did down in Florida. Just a simple kitchen renovation where we had to privately fund all of this just to try out the idea. But most of the time was in the demo. The idea is that you go into the house with a 3D scanner and you scan the room and you pick up the plumbing stub outs, the electrical locations, the electrical box locations, and the window openings. Then you go to the computer and you design the kitchen around those existing conditions, and you're guaranteed when this thing is delivered that it's going to match up to those walls. So literally, really literally, we had this thing installed in a day and a half. It was another 1 day of the demo and the prep work with the new electrical. That was Monday morning. We started on Friday. One last thing. What if we took this to a whole nother scale? Also not far from here is Katrina in New Orleans. After the hurricane in New Orleans, you had all of the FEMA trailers move in, right? Gave everyone, it's great, gave everyone a place to live, but they can't get rid of those things. People got comfortable living in them. They really destroyed the neighborhood because now it's a trailer park. It's no longer a neighborhood. So is there a way we could solve this problem architecturally, with some better architecture? So what we did is, this is another 1 week long project. We designed a crate. This is 8 foot wide and 12 feet long, and you see it's multiple layers. This thing will deploy off of a truck with a forklift. It's a forklift slot. And in 2 hours, unfold to this form. So the walls have windows pre-installed, doors pre-installed, the exterior siding, the interior finishes. We're using a lot of gaskets, so when the walls unfold, they make a seal. The HUD team also liked this idea, so they came out and saw this. This was the installation of the prototype in Orlando after the hurricane that hit Key West. They liked it so much there, they invited us to bring it down to Key West. So this is a couple months later, we went down and we're showing the municipality this. Beauty here is that you can have a 1-bedroom house or double it up and now you have a 3-bedroom house. Or you can stack them and you can have a little apartment building, and this is scalable. It can be a mile long if you want it. So finish it up with this video. And little did they know they'd be roped into helping us set up a house. So this is the early prototype before we got the siding, as part of it. What we're trying to research is, can we make a custom SIPS panel that has an exterior finish already applied and an interior finish? Could it be part of that sandwich? Typical government subcontractors. We priced this out and we could build these for about $40,000 a piece. But the middleman that was pitching this to FEMA upped the price to $80,000, which the FEMA trailer cost the government $72,000 a piece. Believe it or not, they pay that much for those things. So they're just going with what they thought the government would pay. So that's it. That's what we're doing at Virginia Tech. I didn't go too long.
No. Do you have time for questions?
Any questions? Yeah.
Anybody have a question?
Great presentation. I was wondering, if something were to go wrong inside those walls, is it easy to fix? Is it easy to take off? And
So once the house is put together, it's really no different than a conventional home. Cabinets are installed the same way in the cartridge in the factory as they are, conventionally. So, in fact, the big part of what we're doing is, I didn't talk about it, but all of those panels, they're pre-finished panels. They just snap on the walls. This is really be like these panels on the wall. You can pop them off and you can access all the electronics at any time. So we're predicting or proposing that the house of the future that has a lot of electronics is going to need a lot of repair and a lot of upgrading. So we accommodate that with, we're also, the breaker panels, the sub panels, they have snap-on panels that allow access to those. Yeah, good question though. I know the question. How much does one of these things cost?
That was my question.
Was it?
Yes.
I knew it.
And the house that you guys sold, how much did you develop for?
450. 450,000. We built it for right around 375. It included the land. So the idea, the thing is, it's the range. It's the whole range. It depends on how much technology you want in the house. We're working on a project now. It's in the design stage of an affordable housing neighborhood. It's a famous Hollywood person that is doing a lot of really good charity work, and he wants to revitalize this neighborhood that he grew up in. 42 acres, it's a trailer park, and he wants to clear it out and put in affordable, modern housing. It's designed geared towards millennials. Skateboard parks, everything, it's just a really hip neighborhood. And we're really excited that he found us, and he's having us propose some concepts for that. So we're really targeting, a truly affordable house. Not as extreme as the disaster relief, but less than average. The idea is that if you can get a poor family to invest in a house, so subsidize their mortgage, don't just give them, handouts. It's the best way for them to start out, because they have something that's of value, and then when they need to upgrade or go for a bigger house, they have something to sell, it's a starter home. The students are also working on a concept home where it can start as a 1-bedroom, 1-bath, and you can add modules afterwards and build up to a 2-bath, 3 and 4 bedroom. The faculty are always the tough ones.
Oh, well, thank you, but I'm not faculty.
Oh, you're not?
Architects have been fascinated with prefab for over 100 years. So when do you think the future house will be the present house?
what I think is different today is the access to the industrialized equipment. The CNC machinery is becoming more and more and more affordable. I think now any general contractor can really afford to set up a CNC shop and start to industrialize systems. I think it's actually going to happen at a very large scale. It's going to happen at an Amazon or a Katera, or someone just moving into this and realizing that it's very efficient to prefabricate a whole kitchen rather than try and do it on the site. I think it's coming fast in one form or another. Sweden's been doing it for a long time. More of a panelized system, not cartridge system. But they do it because I think, one, their codes are so strict that they have to have really high performance walls. And so they're building these effectively in a factory, and the cost of labor is so high. So I think it's coming. I think it's really fast, like within a couple of years. It's just going to take one group to do it, and everyone's going to follow. Might it be IKEA even.
This Center for Design Research, is it part of the curriculum of the university?
No. No, that's the hardest part of my job, is it's not built into the curriculum yet. And so I have to go through all kinds of gymnastics, work out deals with their professors in engineering and say, hey, they're going to be working with me. Can you be their professor and supervise them on this? Can this be their capstone engineering project? My team, the one that went to Dubai, 22 students, over 4 colleges and 12 departments. So it was really spread out.
So they're not just architecture students?
No. It's architecture students working with all of the other disciplines.
And how, according to your experience on that, how do you see that engagement between multidisciplinary careers with architecture?
How well does it work?
Yeah, how, like, according to what you have seen, is it easy, that connection between different disciplines?
Yeah. Oh, yeah, because they're students. They love working together. And, the great thing about this is the projects just generate excitement.
Yes.
I mean, can you imagine these standing up and getting that trophy, in Dubai and coming back? They're a family now. These guys are bonded for life. So these projects are exciting. If they see in the past where the projects have gone, knowing the project they're working on has the potential of going that far, going to Times Square. Yeah, it's really great for their education.
Time for one more or two more.
Hi, I just want to say thank you. That was an awesome presentation.
Thanks.
I have 2 questions, if that's okay. I guess first question is, how exactly could you use the smart technology to prevent, damage to the existing structure? Is that possible?
One of the things we're working on, not necessarily damage. Are you thinking like
Like
twisters or?
kind of like a preventive kind of measure. Like in the case of like a wildfire or something, could the house kind of respond to that somehow?
We haven't gone there yet. We haven't looked at. What we have been doing is looking at real-time monitoring of the performance of walls, right? Installing temperature sensors inside and outside, looking at the delta T. We're exploring the use of phase change materials in the ceiling. And in half the house we have phase change, the other half we don't. And we're looking at the performance of one half of the house versus the other. Here's a good experiment we're doing. It's with the HVAC. A lot of HVAC technicians will say, you're better off in your home to set your thermostat at one temperature and just keep it there, rather than adjusting it through the night and day and jumping all around. we have a house that has electronically controlled dampers on 5 zones in the house: the bathroom, the bedroom, kitchen, the living room, the entryway. Now with the super energy efficient home and the SIPS panels, now we have super efficient, super insulated spaces that are it takes a very short, a little amount of air to bring it to temperature. And we have integrated occupancy sensors that can tell who's in each room, right? So we're doing real-time kind of bringing the rooms to temperature. What we're able to do is use it as a test bed. So for 1 week, and we're just starting to do this because we just got it back, and you know, it's just, we can't wait to jump in. We'll have a year before the World's Fair to really get in there and really improve all of these systems. But so we have a test bed. We're gonna try with zone control on one, monitor how much energy we use, and do whole house and monitor energy and see which one's best.
And the second question is there a possibility for like the labor to be replaced with like drone technology or like robots, like automated construction? Is that maybe a possibility in the future?
Yeah, it's the way it's going. I mean, look at how cars are produced. The automobile manufacturing doesn't eliminate the labor. You still need people. You still need people to do the work. The robots are just doing the work that people don't really want to do anyway, right? It's a lot of repetitive stuff. It's really bad. So I think there's going to be a lot of efficiency and automation. I'm excited about the precision that you get in automation. You know, go into any house that's constructed, and it's just, you know, a lot of the houses. It's poor craftsmanship. We're losing all our skilled labor.
Did you have chance to have real clients who have actually lived in one of those houses so that you can at least test their satisfaction, if they were happy, how they, you know, social and cultural
I'm going to
wise.
predict they hate the color white. And they hate glass. Right? I mean, this is one model. It's really provocative. We're an architecture school, right? We want to propose the house of the future. In some ways, we make it all white and abstract intentionally to kind of the preconceived idea of what, you know, the detailing or what the decor of a house is, right? It's Jetsons. But the house we did in Charlottesville, a realtor bought that house. He's been living in it for 2 years. Loves it. Absolutely loves it. Well, he got a good deal. Sold it for 2 lives. So of course he's happy. Now, what we can do after, now that we have the house, we're going to have user studies. We had a group come in just yesterday walking through. They say, oh, we're going to be a user study group. I can predict they're not going to like it. They were an 80-year-old couple, and they're going to come in, and the idea is they're going to look at the aging in place kind of aspects of it. But it doesn't, what we have there isn't really the style that you're going to end up with. It can be any style. What we're really looking at is the process of delivering the home. It's an industrialized way, right?
Does anybody have one last question?
I could probably just shout. Yeah, these projects are really intriguing, and it's incredible, I think, how you're preparing your students, I think, for kind of the future of design. And so my question is just, how are you talking to your students about their skill sets that they need and taking them through their education right now? And then how do you see in like a generation or two, what's the future of kind of the architects and designers role?
Well, the first is it's the School of Hard Knocks. Okay, so I recruit first-year students all the time. They're great students. They have great attitudes. They're willing to do anything. Right? The seniors, they've been doing it for a while, and they're like, well, let me just work on the things that you need me for. the students in the first years, they'll pick up the stone, so I try to keep the students across the levels, undergrads and grads and all years, so that we won't end up one year with no students. And the younger students learn from the senior students. And a lot of the senior students are learning from the industry. A lot of times, like the manufacturer of the stone will come in, or of the touch controls, or the actuators. And they work with them, and they teach the students how to program the actuators, or how to, how they're not programmable. And then our computer science guys have to go in and hack into it and make it programmable, right? But yeah, so that's education. It's the best way to learn is to build, especially for an architect, is to build something. All right. The second question was?
Just, I don't know, future role of architects and designers, and given the kind of myriad of technologies that you presented and that might be coming.
It's more just addressing the state of technology that we're in, that we can't ignore it. This is coming on like a freight train. You're going to have automated everything. You're going to voice control everything. The architects need to get in there and grab a hold of this and integrate it well, because if they don't, you're going to have the engineers do it. A lot of the engineers would say, I'm being hard on the engineers, but I've recruited a few engineers to go into architecture. But you know what I mean. We have to address this as architects. Oh,
So
you're
he's
yawning.
Yeah, just for one more.
Yeah, sure.
The last question.
So, integrating technologies is, like, of course, the biggest thing that we're trying to do. How does sustainability, involve into what you're doing in prefab? And how close are we to a net zero prefabricated home?
We're there. Net zero is easy. Energy positive is easy. Photovoltaic panels, home batteries, your electric car. I mean, that's what that house is. That house generates twice the power that it uses. We had so many PVs, a 15 kW array, because we really, the more you came to a competition with, the better you're going to do. We could cut those in half and still be an energy positive building. We're using solar thermal. We're making our own hot water. Hot water is a big consumption, energy consumer, right, in the house. It takes a lot. Once our solar thermal went down and we had to use electric resistance in the water tank, and the electrical guys just went nuts. They're like, what happened? In the middle of the night, there's a spike. It's beautiful because you see right now, living in our homes, we don't see where our energy goes. We have no idea. You turn on lights, your refrigerator, is it your fridge? Is it your heating system? Is it your air conditioning? Now with the interfaces we have, you can go on any of the 11 panels on the walls and bring up one page that shows your energy distribution, shows where the power is going. So you can turn on a light and see the difference. So sustainability, there's no better way to build sustainably than off-site. The efficiency of building in a controlled environment, you can guarantee the use of sustainable materials, no substitutions, the economy of scale, limiting waste, and then there's no better way to be sustainable than to design an energy efficient home, right? Sophisticated envelope. Right? So we're there. I mean, it's not hard. Even with conventional housing, it's not hard to get the technology to make it energy positive.
Thank you so much, Chip.
Oh, thank you.